Hello, class. This will be the recorded lecture for chapter 4 in our stats book. We're going back to linear regression analysis. The book order is a little bit weird, but we'll do the best we can to introduce it and still follow the way the homework is set up. But the idea of linear regression analysis is a concept more algebraic than what I would consider statistical. That's kind of why I like it. And the idea is that you're going to take a set of data and try to take the data and generate an equation that best fits the data. And then you can do predictions. And to be honest with you, that's what I typically do with data, not the analyzation statistics wise, but be able to model it with equations and then be able to make predictions by using that equation, plugging in numbers, and out comes your prediction. So that's what we're going to do in this section. And to get started, what I'd like to do is do a quick review of the algebra idea that we are going to be doing, which are linear equations. So let me pull up the whiteboard here. So I'm going to do it in the algebra form, and of course stats uses a little different variables, but we'll coordinate that when we start talking about the stats calculation for these equations. So just to remind hopefully everybody that a linear equation in algebra would be set up as y equals mx plus b, where m is the slope, and that's the rise over the run, or sometimes we talk about it, the change of the y variables over the change of the x variables. And if you calculated that given 2 points, it would be y2, y1 over x2 minus x1. And the b is actually the y-intercept, and that's where the value, or that value is where it crosses the y-axis. So we're going to deal with what's called the Cartesian coordinate system, or sometimes called the rectangular coordinate system, or the horizontal axis is the x-axis, and the vertical axis is the y-axis. So we call the x variable as the input variable to the equation, or sometimes it's called the independent variable. And the y variable is the output, or sometimes called the dependent variable. So what we're going to be doing is taking a bunch of data and first plotting it. And when you plot it, what we call that is something called a scatter plot. And so you would just plot the data the way it ends up. And what you'll be given is a value of x and a value of y, and you would just plot it. Well, remember that when you go to the right, this is positive. So call that 1 and 2. When you go to the left, it is negative. And when you go up in y, that's positive. And when you go down in y, that would be negative. So the strategy will be to generate the scatter plot. And then back in the day, there would be a way that you could estimate what the value of m is and what the value of b is. And then you would generate something called a correlation coefficient to see how good the equation matches the data. And so if it matches it very well, the number gets close to 1 or -1, depending on the slope. And if if the equation or the model is not very good, then the correlation coefficient goes closer to 0, which means there's not a good correlation. And so before we do all that, let's talk about it in a more theoretical way. And the theoretical way is let's take a look at an equation here and talk about how it would be graphed in the old algebra days. So say like we take this equation, y equals 2x plus 3, or plus 1. And so let me generate my graph here. And so the way to think about this is, as I said, the x value is the input and the y value is the output. So what we mean by the y-intercept is that when your independent variable is 0, the output is the y-intercept. And so in this case, when you plug 0 in for x, 2 times 0 is 0 plus 1. So y equals 1. So let me put a few things on here. So that's 1, 2, 3, minus 1, 2, 3 in the y direction. And so if we plot that, and we'll do that in red, it would be x equals 0, y equals 1. It would be right here. So what do we mean by the slope? Well, the slope is the rise over the run, or the change of the y value over the change in the x. And 2 is positive in this case. So what do? Well, you could start plugging more numbers in and plot them. And that's one way to do it. But I want you to understand what the slope means. And what the slope means is that if it's positive, remember, y positive is up and x positive is to the right. So if we go, say, up 2 in the y, then we would have to go positive 1 in the x. And so this would be point x equals 1, y equals 3. And so if you plug that 1 into this equation, right, when x equals 1, 2 times 1 is 2, plus 1 is 3. So you see they correspond to one another. Also, if you went down, right, that's negative in the y, and to the left is negative in the x. And remember that if you have, and you're dividing two numbers like minus 3 divided by minus 1, that equals plus 3, right? So remember, when you have two negatives, you end up with a positive. So you could also go the other direction with the slope. And so say like instead of going up, we go down 2, so that's minus y. So then we have to go minus x as well. So we come over here. And so that point would be x equals minus 1. And that would be y equals minus 1 as well. And when you plug it into that equation, you see it actually gives you the correct number. And you could see we can connect this with the straight line. And that would be our sketch or graph of that equation. So what we're going to do with the stats or statistics and data is try to find M and B. So we're only doing linear regression analysis. And so that's the good news. Okay, one more quick thing, and then we'll call this one. And let's take a look at what happens if we have a negative slope. So I guess I could have put it on pause, but I'm almost done now. Okay, so say like we do y equals minus x plus 1. So now our y-intercept is going to be 0, 1, because that is b, and our slope is minus 1. So if we take a look at this, and see how this is going to look like. The way that would work again is we'd have 0, 1 again, would be our, let me do it in red. That would be our y-intercept. So now if we want to go negative slope, I could draw our little table again, x and y. So when x is 0, y is 1. And so say like we wanted to move with the negative slope. So if you go positive y, then you have to go negative x. You see, 1 has to be positive and 1 has to be negative, right? Because minus 1 divided by 1 is minus 1. So if you have an odd number of negatives, when you do the arithmetic operation of multiplication or division, you get a negative number. So if we go up 1 and y, then we have to go to the left of x. So that would be right here. So that means when x is -1, you plug -1 in here and you get minus a -1 plus 1. So that would be 1 plus 1, which is 2. And that was the point there. Or if you go down in y, which would be negative, then you would have to go to the right for x, which would be this point here. So that would be x equals 1, y equals 0. And you see when you plug that into the equation, you get -1 plus 1, and you get 0. So this is the example of a negative slope. So again, what we're going to be calculating is actually 3 or 4 values. We're going to find out what the slope is. We're going to find out what b is, or the y-intercept. We're also going to find this coefficient, correlation coefficient as well, to see how this calculations go. And the good news is that you'll see that technology is very, very handy in this calculation. It is really tedious. So here's what we're talking about. We're going to take 2 variables. One will be the input, one will be the output. And we're going to generate this thing called a scatter plot. And if it looks like we're going as y goes up, right? X goes up, we have a positive association, which means a positive slope. And this would mean as y goes down, x goes up, right? So as we go down, we're going to the right. This would indicate a negative slope, as I indicated there. So I think this is a good place to stop. So this ends the first of a few recorded lectures we'll have in chapter 4. And this is just the introduction of linear